Before we start solving simultaneous equations, we're going to just refresh your memory a little bit on solving a regular linear equation, right? So, for example, if I have the equation 2x plus 5 is equal to 17, right? And I need to solve that equation. Well, the objective of solving any equation is to find out what the unknown quantity is equal to. The unknown quantity here, x, is called a variable, right? 2, the number directly in front of x, which essentially tells us how many x's there are, is the coefficient of x. 5 and 17 are called constants. Numbers by themselves are called constants, right? And of course, your add is your sign, all right? And well, equal sign. So the objective of solving any equation is to figure out what x is equal to or what the variable is equal to. In this case, 2x plus 5 is equal to 17. This literally means 2 times some unknown number x plus 5 will give you 17. That's what it means, right? So there are several ways to solve equations. There's a balancing method, there's transposition. So the balancing method is where you do the same thing on both sides of the equations, sorry. And then transposition is when you move terms from one side of the equation to the other side of the equation, right? So my preferred method is transposition. So I just want to end up with x on this left-hand side. I want to move everything else to the right-hand side. I want to end up with x alone because I want to know what x is equal to. So with transposition, when you move a term from one side of the equation to the other side, you do the opposite of the operation or the inverse of the operation. So here it's 2x plus 5 is equal to 17. The first thing I want to do is I want to get rid of this plus 5. So to move or transpose plus 5 to the other side of the equation, well, 17 is going to remain there, but to remove plus 5, not remove, but to transpose it from the left-hand side to the right-hand side, I will have to minus it, right? So because minus is the opposite of plus. So 2x plus 5 is equal to 17 will then give me 2x is equal to 17, take away 5. And then then you simplify that. So 2x would be 17 take away 5 is 12. And therefore, if 2x is equal to 12, this literally means 2 times x. So x would be equal to 12 divided by 2, which makes x equal to 6. Right? And to check if my answer really does make sense, I will substitute 6 back into the original equation, replacing x with 6, and see if that makes sense. Well, it does, because this is how you check if your answer is correct to any equation, right? By substituting the value that you get for the variable back into the original equation. So remember, 2x plus 5 is equal to 17, literally means 2 multiplied by x. So I'll put 6 in brackets like this. So 2 times 6 plus 5, well, 2 times 6 is 12, and 12 plus 5 is actually 17. It makes sense. So I know that my answer is correct. Now, if I had gotten a different number, like for instance, let's say I had gotten x as 3. Well, that would mean that 2 times 3 plus 5 is equal to 17 because that's the original equation. But that is not correct because 2 times 3 is 6 and 6 plus 5 is 11. And 11, I should put a question mark here. Yeah, 11 is not equal to 17. So 3 is not the answer. So this is how you check to see if the answer to your equation is correct by substituting the value that you get for it back into the original equation to see if the left-hand side is actually equal to the right-hand side. What we got first is 6, and when you substitute that into the left-hand side, it does in fact give you 17. because 2 times 6 is 12 and 12 plus 5 is 17 and 17 is equal to 17. And then I showed you here that if you had gotten another number, for instance, you had gotten 3, that would not be correct because when I substitute that into the original equation, I end up with 11 is equal to 17, which is not true, right? So that's why I know my answer is correct. All right, guys? Soraya, following?
Yes, Miss.
Okay, what about you, Josh? Everything's okay so far?
Yes, please.
Great. Faith and Matthias, how we going there?
English.
Good.
Okay. What about you, Zane? Following, honey?
Yes, sir.
Okay, great. So I just wanted to revise this core concept because solving simultaneous equations, it's all about solving equations, right? Now, previously, you would have solved equations where you have one unknown value. So like in this one, for instance, the unknown value was x, right? However, solving simultaneous equations, it's solving equations when there is more than one variable, meaning like you could probably have x and y, right? And there are two methods. So the first method that we are going to look at is called the elimination method, right? So we're going to look at the elimination method for solving simultaneous equations. All right, so the first example would be solve. Let's say we have x plus y is equal to 5, and then 3x plus y is equal to 7. So I want to solve these two equations. And as you can see, we have two variables. We have x and we have y, all right? Unlike the last one where you only had one variable, and that's why you only had to solve one equation. But in this one, in this example here, we have two variables, and that's why we have two equations, right? So if you had three variables, like you had x plus y plus z, you would need three equations. That's how it goes, right? So the first thing that you do when you're going to solve a pair of simultaneous equations, you're going to label your equations. So I'm going to label this equation 1 and this one equation 2. Right, so my first step was to label the equations. Now, when you are using the elimination method, as the name suggests, we are going to eliminate one of the variables, right? Because we only know how to solve an equation with one variable. So we're going to eliminate one of the variables in order to just have one variable. So we're going to end up with just x or just y, right? So what we're going to look at first, we're going to look at the coefficients of x and y in both of the equations, right? So the coefficients of x in equation 1 is just 1 because it's just x, right? So the coefficient of x here is 1. This is literally 1x. And then the coefficient of x in equation 2 is 3. All right. Then we look at the y's. The coefficient of y here is 1, and the coefficient of y in the second one is also 1. So we know that we can use the elimination method right off the bat because in order to use the elimination method, the coefficient of the variable in both equations has to be the same, right? So it's not the same for x, but it is actually the same for y. So I'm going to take this time now to write down that hint, right? Or I shouldn't say hint, but it's a rule basically, right? So in order to use the elimination method, the coefficient, and I want you all to write this down. This is a note. The coefficient of the variable in both equations, right? So the coefficient, sorry, of the variable in both of the same variable, I should say, right? In both equations must be the same. So meaning that it's either the coefficient of x is the same or the coefficient of y is the same, right? And in this equation, Hold on, I don't like that it's this bold. I want to change it to regular. Yeah. So in this equation, in these two equations, sorry, the coefficients of y are the same. They're both 1, right? So in the equations above, the coefficients, gosh, the coefficients of y in both equations 1 and 2 are the same, right? It's 1. You have 1y here and you have 1y there. So the coefficients in both equations are the same, and therefore we can go ahead and we can use elimination, right? So the criteria to use elimination is that the coefficients, or if I do that, both of them will be, okay, yeah. The coefficients have to be the same. Next, what we do is we are either going to, so if you have y and y, right? So I have y and then I have y, and I want to eliminate that. So essentially, I want to get that to be equal to 0. What would I do here, guys? Would I say y plus y is equal to 0 or y minus y is equal to 0?
Y minus Y.
Correct. I'll say y minus y is equal to 0, right? Now, when you're dealing with equations, you have to actually do the same thing to the whole equation. Otherwise, you're going to be changing the equations. So I can't just say y take away y and get rid of it. What I would have to do is I would have to subtract. I'll say equation 1 take away equation 2. Or in this case, I might actually say equation 2 take away equation 1, right? So I'm going to say I'm going to subtract the two equations, right? So I'll say equation 2 take away equation 1. So what that means is, well, equation 2, let's just write it back, right? Equation 2 is, hold on, let me take this off. Right, equation 2 is 3x plus y is equal to 7. That is my equation 2, right? And my equation 1 is x plus y is equal to 5. So what I'm going to do now is I'm going to subtract. I'm going to say equation 2 take away equation 1. And to do that, I'm going to subtract every corresponding term, right? So I'll say 3x take away x, which will give me 2x, right? Because 3x take away x is 2x. Y take away y is 0. And then 7 take away 5 is 2. Right? So what I have done, I have subtracted the entire equation 1 from equation 2, and in so doing, I have eliminated y. So all I'm left with is 2x is equal to 2, right? So that is the second thing. If once the coefficients are the same, you then look at the signs of the coefficients. So because they're both positive, I have y and y. Well, to get that to be equal to 0, I'll have to minus them from each other. So y take away y is equal to 0. So that way I got rid of it. But like I said, you cannot just take away the y's. You would have to take away the entire equation from each other. Now, the reason I didn't do 1 take away 2 is because equation 1, as you can see, have smaller numbers. So I would have ended up with negative numbers. That does not matter, okay? It doesn't matter if you have negative numbers or not, because even if you have negative numbers, you could still work it out. Just use your rules of negative numbers. So now I'll say, well, 2x is equal to 2, so therefore x would be equal to 2 divided by 2, so that makes x equal 1. And now that I know what x is equal to, I can substitute that back into any one of the equations, whether 1 or 2, and I could now solve for what y is, right? So now I will substitute x is equal to 1. And I'm going to substitute it into equation 1 because that's a simple equation. So wherever I have x in equation 1, I'm going to replace it with 1. So this would be 1 plus y is equal to 5. Well, I already know y is 4 because 1 plus 4 is 5. But anyway, by algebra, this would be y is equal to 5, take away 1. So y is equal to 4. And therefore, my solution to this pair of simultaneous equations would be x is equal to 1 and y is equal to 4. So I'm going to go over all these steps with you again, right? I'm solving a pair of simultaneous equations using the elimination method. The elimination method allows us to eliminate or get rid of one of the variables so that you can solve for the other one and then substitute it back, right? So I was trying to solve the pair of simultaneous equations x plus y is equal to 5 and 3x plus y is equal to 7. The first thing that I did is I labeled my equations. And this is very important, by the way. You have to actually do these little things. Like you have to label it and you have to say what you're doing throughout, right? So I label my equation 1 and equation 2. In order to use elimination, the coefficients of the same variable in both equations must be the same. So at this point, we looked at the coefficients of x in both equations 1 and 2, and we also looked at the coefficients of y in equation 1 and 2. We saw that the coefficient of x in equation 1 is 1, and the coefficient of x in equation 2 is 3. So x does not meet the conditions or criteria to use elimination. However, with y, the coefficient of y in both equation 1 and 2 is 1 and 1. So it has the same coefficient. And once it has the same coefficient, I could go ahead and use the elimination method. The next thing I did now is I asked myself, well, I have y and I want to get rid of it. So if I have y and they're both positive, in order to eliminate it, I would subtract it from each other. So I'll say y take away y because I need to get that to be 0. So y take away y is 0, but you cannot just take away the y's. You would have to subtract the entire equation from each other, right? So I rewrote my equations. I put 2 on top of 1 because 2 had the bigger numbers. It does not matter. You could have done 1 take away 2 and you would have still gotten the correct answer, right? So I said equation 2 take away equation 1, and that means that I have to subtract all the corresponding terms. So 3x take away x is 2x, y take away y is 0, and 7 take away 5 is 2. So I ended up with 2x is equal to 2, and therefore x is equal to 2 divided by 2, which means x is equal to 1. Notice that I have my annotations, right? I have my equations labeled and I have the steps that I'm following. So I said 2 take away 1 before I carried out the subtraction. Once you get the value of one of the variables, you can then substitute that back into any one of the equations to find out what the other variable is. So I know what x is, so I substitute x is equal to 1 into equation 1. I chose equation 1 because it's just a simple equation, x plus y is equal to 5. So I substituted x is equal to 1 into x plus y is equal to 5. Wherever I have x in that equation, I replace it with 1. So instead of x plus y, it will be 1 plus y is equal to 5. And if 1 plus y is equal to 5, then y is equal to 5 take away 1, and therefore y is equal to 4. Now, when we just started the class, I told you in order to check if your answer is correct, you need to substitute the values that you got for your variable back into the equation to see if the left-hand side is equal to the right-hand side. Well, when you are solving a pair of simultaneous equations, you have to do it in both equations, right? So I'm going to check if my answer is correct by substituting x is equal to 1 and y is equal to 4 into the two equations to see if I get 5 and 7 respectively. So if x is 1 and y is 4, then for equation 1, that would be 1 plus 4. which is equal to 5. So it works for the first equation. Now to check for the second equation, that would mean 3x, so 3 times 1, which is 3, plus y, which is 4. So 3 times 1 is 3 plus 4, and that is equal to 7. So I know that my equation is correct. All right, so let us now look at another example. First of all, everybody got this down in their books? Anybody need some extra time to write it down? Faith, you got it?
Yeah.
Josh?
Yes, please.
All right, Matthias, you have it?
Yeah, miss.
All right, it's Soraya.
Yes.
Okay, Matt. And, oh, sorry, I asked Matt already. Zane, you got it, honey?
Yes, miss.
Okay, great. All right, so let's move on to another example. So this is the exercise we're going to start. I'll start with you. So let's say we have to do x plus y is equal to 5. All right, that's my equation 1. And then 4x plus y is equal to 14. That's my equation 2. Soraya, can we use elimination for this pair of simultaneous equations?
Yes, miss.
Why?
Because there's only two types of variables.
Yeah, but what about in order to use elimination, the coefficient of one of the variables, well, the same variable in both equations has to be the same, right? So which of the variables have the same coefficient, x or y?
X,
No, x does not have the same
Y.
coefficient. It has to be y because the coefficient of x here is 1, right? And the coefficient of x here is 4. But however, with y, the coefficient here is 1 and the coefficient here is 1. So I can go ahead and use elimination. All right? So what I do now is I've already labeled my equation, guys. So I will now subtract them because once you have the same signs, so that's a note, right? That's a note, by the way. Once the coefficients are the same and the signs are the same, you subtract the equations from one another. So same coefficients with same signs means that you will subtract the equation. Same coefficients with same signs. And what do I mean by same signs? They're both positive, right? So they both have plus and plus in front of it. So same coefficients with same signs means that we subtract the equations, right? So in this case, you have plus 1 and plus 1. So therefore, I would subtract them to give me 0. So I could get rid of it. So what I'm going to do now is going to say equation 1, take away equation 2. And that will give me, well, I'm subtracting the corresponding terms, right? So I'll say x take away 4x. Now this is 1. So 1 take away 4 is negative 3. So negative 3x. Y take away y is 0. And 5 take away 14 is negative 9. So if negative 3x is equal to negative 9, then x is equal to negative 9 divided by negative 3, which makes x equal to positive 3. And once I got what x is, I can go ahead and substitute that. So substitute x is equal to 3 into any one of the equations. I'm going to use equation 1 since it's a simpler equation. So wherever I have x in equation 1, I'm going to replace it with 3. So it's x plus y, so therefore that would be 3 plus y is equal to 5. If 3 plus y is equal to 5, then y would be equal to 5 take away 3, which gives me 2. So my solution to this pair of simultaneous equations would be x is equal to 3, y is equal to 2. And to just double check if my answer is correct, I'm going to substitute x is equal to 3 and y is equal to 2 into the two equations to see if it works out. So the first one is x plus y is 5. So that would be 3 plus 2, which is actually equal to 5. So it works out for the first equation. For the second equation, it's 4 times 3 plus 2. So 4 times 3 is 12, and 12 plus 2 is 14. So it also works for the second equation. So my solution is correct. We're going to look at another one. All right, so we have 5x plus y is equal to 14, and then 3x plus y is equal to 10. Faith, can we use elimination here?
Yes,
Why? Why can we use
because
it?
the two y's have a coefficient of 1.
Correct, because the two y's have the same coefficient. And since the signs are the same as well, I will subtract the equations. So my first thing, don't forget to label the equations. You have to do that in order to write your annotations properly. So now I'll say equation 1, take away equation 2. So I'll say 5x take away 3x, which gives me 2x. Y take away y is 0. And 14 take away 10 is 4. So if 2x is equal to 4, then x is equal to 4 divided by 2, which makes x equal to 2. And now that I know what x is, I can substitute that. So sub x is equal to 2 into any one of the equations. I'm going to do it in equation 2 this time. So wherever I have x in equation 2, I'm going to replace it with 2. However, I have to use brackets because in equation 2, it's 3x, which literally means 3 times x. So that would be 3 open brackets, 2 close brackets, plus y is equal to 10. Notice I use brackets. If I did not use brackets, that equation would now change to be to the 2 plus y, which is not correct, right? It's 3 times x, not 3x, as in like nothing between both of them, right? 3x literally means 3 times x. So 3 times 2 is 6. 6 plus y is 10, and therefore y is equal to 10 take away 6, which gives me 4. So my solution to this pair of simultaneous equations is x is equal to 2 when y is equal to 4. And to check to see that I have the correct answer, I substitute x is equal to 2 and y is equal to 4 back into the original equations to see if it makes sense, right? So let's see. It'll be 5 times x, which is 2, plus y, which is 4. 5 times 2 is 10 plus 4, which is 14. So that works out. See, it works out. And then the second one is 3 times 2, because it's 3 times x, plus y. So 3 times 2 is 6, and 6 plus 4 is 10. So my solution does actually make sense, right? So again, to figure out which equation to use, to figure out if you can use elimination, well, the coefficients of the variable has to be the same in both equations. And if it's not the same, we'll go on to that afterwards. But once it's the same, you can go ahead and use elimination. The next thing you look for is what is the signs, right? So the examples that we are currently looking at, the signs and the coefficients are the same. So when you have the same coefficients with the same signs, you subtract the equations from one another. Okay, I'm going to do one more with you before I give you all some to try for me. Right, so let's say we had 2x plus, actually, we've been doing y's all the time. So instead, let's say I have 3x plus 2y is equal to 33, right? And then 3x plus y is equal to 20. Oh, sorry, this should have been 23. I wrote down everything. Yeah, 23. And then 3x plus y is equal to 22, right? So this is equation 1, and this is equation 2. Guys, notice that the coefficient of x in this case is the same. And it's not 1, it's 3, right? It doesn't matter. It doesn't have to be 1. It could be any number, all right? And it could even be negative. But in this case, they're both positive 3. So once you have the same signs with the same coefficients, you subtract the equations. So I will say equation 1 take away equation 2, and that would give me, well, 3x take away 3x is 0, 2y take away y is y, and then 23 take away 22 is 1. So that's it. That's the solution for y there. There's nothing else to work out, right? In terms of y. So y is equal to 1, and now I substitute y is equal to 1 into any one of the equations. I'm going to put it in equation 2. That's a simple equation. So that would be 3x plus y, which is 1 that we just worked out, is equal to 22. If 3x plus 1 is 22, then 3x is equal to 22. Take away 1, which means that 3x is equal to 21. And so x is equal to 21 divided by 3, which gives me 7. So my solution here is x is equal to 7 and y is equal to 1. And to check that my answer is correct, I substitute x is 7 and y is 1 back into the original equation. So that would be 3 times 7 plus 2 times 1. Well, 3 times 7 is 21, and 2 times 1 is 2. 21 plus 2 is 23. So it works out in the first equation. And then in the second one, 3 times 7 again, plus 1, which is y. So 3 times 7 is 21, plus 1 is 22. And therefore, my solution is correct. At this point, guys, we're going to pause for a little while. I'm going to give you all some to do to try for me. Got it. So the first thing, we label our equations 1 and 2. And now we look to see which one has the same coefficients. It is B, and it's the same sign. So we subtract the equations. So equation 1 take away equation 2 would be 2a take away 4a, which is negative 2a. B take away b is 0, and 11 take away 17 is negative 6. If negative 2a is equal to negative 6, a would be equal to negative 6 divided by negative 2. So that makes a equal to 3. Negative divided by negative is a positive. Once we get that, we substitute a is equal to 3 into any one of the equations. Let's say equation 1. So that would mean 2 times a, so 2 times 3 plus b is equal to 11. So then 2 times 3 is 6. 6 plus b is equal to 11. So b is equal to 11 take away 6. That makes b equal 5. Right? Checking the solution is not part of your solution. It's just doing it. I'm just showing you how to do that for your own sake, right? So if A is 3 and B is 5, then that would be, you substitute that into the original equations to see if it makes sense. So 2 times 3 plus 5, well, that does give me 11. So that it works out in the first equation. And then in the second equation, 4 times a, so 4 times 3 is 12, plus 5, which is 17. So it works out in the second equation. All right. Let's do the next one. If you didn't get those answers, please check to see where you went wrong and correct it, okay? The second one is 5x plus 2y. Right, so that one was 5x plus 2y is equal to 14. And then 7x plus 2y is equal to 24. No, 22, sorry. Right? Guys, part of your solution, though, is writing in these annotations. If you do not do that, you're going to get it wrong. You're going to lose marks, right? So part of it is actually putting in those annotations, meaning you have to label your equations and then you have to write the annotations like one take away two or substitute A into like that. That is part of the solution. All right. So the y's have the same coefficient here, which is 2, and they're both positive. So I subtract equation 1 from 2 or 2 from 1, however you want to do it, right? So I'm just going to subtract it as it's written here. So I'll say 1 take away 2, which means that I'm taking away the corresponding terms. So I say 5x take away 7x gives me negative 2x. 2y take away 2y is 0, and 14 take away 22 is negative 8. So if negative 2x is equal to negative 8, then x is equal to negative 8 divided by negative 2, which gives me positive 4. So x is equal to 4. It does not matter which one you decide to subtract first or which one, like it doesn't matter if you say 1 take away 2 or 2 take away 1. You're still going to end up with x is equal to 4. And once you get what x is equal to, you substitute that. So we substitute in x is equal to 4 into any one of the equations. I'm going to do it in equation 1. So 5 times x, which means 5 times 4, plus 2y is equal to 14. So 5 times 4 is 20. 20 plus 2y is equal to 14. So then 2y is equal to 14. Take away 20. So y is equal to 14 take away 20, which is negative 6. And therefore, y is equal to negative 6 divided by 2, which makes y equal to negative 3. All right, guys. So your answer could be negative as well. Your answer can be negative as well as it doesn't have to be a whole number, by the way. The answer could be a fraction too, or an improper fraction, a decimal. It doesn't have to be a whole number. It just so happens that all of these that we did so far were all they were all whole numbers, but that may not always be the case, right? Neither will it always be the case where they're positive. Sometimes the answer can be negative. And in the same breath, just like you could check your answer with the positive numbers, you can check your answer with the negative numbers as well. So it's 5x plus 2y. So let's see. 5 times x, which is 4, plus 2 times negative 3. Well, that would give me 5 times 4 is 20 plus negative 2. Sorry, 2 times negative 3 is negative 6. So 20 take away 6 is actually equal to 14. So that is correct for equation 1. And then similarly for equation 2, it's 7 times x. So 7 times 4 plus 2y, so plus 2 by negative 3. 7 4s are 28, and then 2 times negative 3 is negative 6. So 28 take away 6 is actually 22. So it does work out as well for number 5, right? So the answer there is when x is equal to 4, y is equal to negative 3, right? So I think I made a mistake in one of your solutions. Actually, no, it's correct. Good. Let's look at number 6. Number 6 was x plus 2y is equal to 12. All right, that's the first equation, equation one. And then the second equation is x plus y is equal to 7. All right, so again, you look to see which variable has the same coefficients. It's x because in both equation 1 and 2, the coefficient of x here is 1. So you say equation 1 take away equation 2, x take away x is 0, 2y take away y is y, 12 take away 7 is 5. So y is equal to 5. There's no more equation there to solve. So we get that y is 5. You can now substitute y is equal to 5 into any one of the equations. I'm going to put it in equation 2. It's a more straightforward equation. So that will give me x plus 5 is equal to 7. So x is equal to 7 take away 5, which makes x equal 2. So your solution here is x is equal to 2 when y is equal to 5. That is a solution. Right. The next one that I gave you all, number 7, is 4p plus 3q. Okay. So 4p plus 3q is equal to negative 5. And I told you I'll be careful with the negative signs here. And then 7p plus 3q is equal to negative 11. And that is my second equation, right? So the variable I am eliminating is q because in both equations, it's the same coefficient for q. So I'll say equation 1, take away equation 2. That would mean 4p take away 7p is negative 3p. And then guys, this part, negative 5 take away negative 11. I'm actually going to write that out so you could see it. Negative 5 take away negative 11 would actually be, well, negative 3p on this side. This would actually work out to be negative 5 plus 11, right? Because this negative and this negative will change into a positive. Two negatives make a positive, right? So negative 5 plus 11 is positive 6. So negative 3p is equal to 6, and therefore p is equal to 6 divided by negative 3, and that gives me negative 2. So now I substitute p is negative 2 into the equation, let's say equation 1, right? So that would be 4 times negative 2 plus 3q is equal to negative 5. So 4 times negative 2 is negative 8. 3q is equal to negative 5. So you keep 3q on the side. 3q would be negative 5 plus 8. So then 3q would be equal to negative 5 plus 8 is positive 3. So therefore q is equal to 3 divided by 3, which makes q equal 1. So your solution here, right, would be x is equal, sorry, not x, oops, p. P is equal to negative 2 and Q is equal to 1. That is your answer for question 7. Negative 2 and 1. All right, and then the last one that I gave you all, oh, that was the last one there. Yeah. So I want you all to pay attention to the solution, right? Look at your solution, and all of y'all didn't send me a work, so I didn't really get to see all of your solutions, but check for yourself, right? And see where you might have gone wrong, right? Either with these signs or maybe just working it out, but check it back, okay? At this point, I'm going to give you guys a short break. So it's 5:37. We can resume at 5:50. right? 550, and then we'll do some more examples. Right, so the variable that we are eliminating would always be the one that has the same coefficient. So you see how you have 5y and 5y there? We're going to eliminate 5y. And since the two signs are the same, they're both positive, I'm going to subtract the equations. So I say equation 1, take away 2. I always do like equation 1, take away 2. Sometimes I switch it up. If I don't want to work with negatives, I might do 2 take away 1 if 2 had bigger numbers. But sometimes also it's just easier to see it this way because I could easily say, well, equation 1 take away 2 would mean 12x take away 9x, which will give me 3x. And then 5y take away 5y is 0. And 65 take away 50 is 5 take away 5. 5 take away 0 is 5, 6, 15. Right? So if 3x is equal to 15, that means 3 times x is 15. So x is 15 divided by 3. So I kind of just like to do it that way because I could see them right in front of me in order already. 15 divided by 3 is 5. And since I got x is equal to 5, I now substitute that x is equal to 5 into any one of the equations. Let's do equation 1. So that would be 12 times 5, since 12, it's 12 times x. So 12 times 5 plus 5y is equal to 65. So 12 times 5 is 60. 60 plus 5y is equal to 65. That means 5y would be equal to 65, take away 60. So 5y is equal to 5, and y is equal to 5 divided by 5, which makes y equal to 1. So the solution here to this pair of simultaneous equations would be x is equal to 5 and y is equal to 1. All right, the next question, let's do another one. 3x plus 4y is equal to 15, and then 3x plus 2y is equal to 12. Again, first things first, label your equations. So this is equation 1, and then this would be equation 2. The variable that I'm going to eliminate here would be x because the coefficient is the same in both equations 1 and 2. You have 3x and 3x, right? These are both positive. So 3x and 3x, same signs. You subtract the equations. So we say equation 1, take away equation 2. All right, so 3x take away 3x is 0. 4y take away 2y is 2y. And then 15 take away 12 is 3. So in this case, y is equal to 3 over 2. And you can leave your answer as that. You can leave your answer as improper fraction. You could change it to a decimal. However you want to work with it is fine. All right. So now I will substitute y is equal to 3 over 2 into any one of the equations. Let's say equation 1. So this will give me 3x plus 4 multiplied by 3 over 2, because that's what we got y as, is equal to 15, right? And now what I could do is I can simplify here. So 2 into 2 is 1. 2 into 4 is 2, and then 2 times 3 is 6. So this will end up being 3x plus 2 times 3, 6 is equal to 15. And therefore, 3x will be equal to 15 take away 6. So 3x is equal to 15 take away 6 is 9. And then x would be 9 divided by 3, which makes x equal to 3. So your solution for this pair of simultaneous equations would be x is equal to 3 and y is equal to 3 over 2. So you can actually get an improper fraction or decimal, right? You could have changed this to 1.5 if you wished, or you could have changed it to 1.5. It really does not matter. You're still going to get the same answer because that's just the same number anyway in different representation, right? Let's do one more, and that would be it for today. Okay, guys? So let's say we have um 2x plus 3y is equal to -8. So that's my first equation. I'm labeling it one time. And then I have 2x plus y is equal to -4. That's my second equation. All right, so again, I have 2x and 2x, right? So once you have the same coefficient, you could go ahead and eliminate. And on top of that, it's the same sign because they're both positive. So I'll say equation 1, take away equation 2. 2x take away 2x is 0. 3y take away y is 2y. Now here, I'm writing this out because this is where students make mistakes. So -8 take away -4, right? -8 take away -4. So this will be 2y is equal to -8 take away -4 will actually be -8 plus 4. So 2y is equal to -8 plus 4, which is -4. And then y is equal to -4 divided by 2, which makes y equal to -2. Once you get what y is, we can substitute y is equal to -2 back into any one of the equations. I'm going to put this in equation 2 to see what x is. So wherever I have y in equation 2, I'm replacing it with -2. So 2x plus -2 is equal to -4. Well, this would end up really being 2x take away 2 because plus and minus will change to a minus. 2x minus 2 is -4. That would mean that 2x is equal to -4 plus 2, which gives me 2x being equal to -2, and then x is equal to -2 divided by 2, which gives me -1. So the solution here is x is equal to -1 and y is equal to -2. And that's your answer. All right, guys.